everyone, and hope you all are having an amazing day. Welcome back to my YouTube channel Physics Unlocked. Today we are going to start a new lecture series on motion in a circle, which is chapter number 12 of the A-level curriculum, and also a topic covered by Karachi and Federal Boards among others. In this lecture, I will be defining some key concepts such as radians and angular speed and exploring their relation with the linear speed. We will also work through some example problems to help reinforce your understanding. So let's get started. Okay, so students, how we are going to define 1 radian. So let's draw a circle and let point O be its center and the length R be its radius. Okay, now let me take this length R and place it here at this point like this, R. Now all I do is to push it onto the circumference of the circle of length, and this blue part is still equivalent to the radius of the circle. If I erase this line, what I have done, I have made this radius a little bit curved and push it onto the circumference of the circle. Now I will again make one more radius from the center of the circle to the other end of this arc, and it has the same length which is equivalent to the radius of the circle. Students, one thing which you have to remember, that this arc length is equivalent to the radius of the circle, and the angle that is formed here, it is equivalent to the 1 radian. So how we are going to define radians? So students, as you can see from the figure, this is the center. Center is highlighted by O, and this is the radius R, and this is the length of the arc symbolized S, but it is the length of this arc is equivalent to the radius. So how we are going to define 1 radian is defined as the angle subtended. Okay, it is the angle subtended at the center of a circle by an arc equal to the length, equal in length to the radius of the circle. So you can see the mathematical definition is, if we divide the length of the arc with the radius of the circle, then we will get this angle that is equivalent to the 1 radian. Length of the arc is symbolized as S and the radius of the circle is symbolized as R. So if I am going to write the angle in radians for a complete circle, it would be the length of the arc will be the circumference of the circle, which is equivalent to 2 pi r, and the radius of the circle is r. And if I cancel out r with the r, then in a complete circle 1 radian is equivalent to 2 pi radians. Like in degrees, the complete circle is equivalent to 360 degrees. Okay students, so next concept is angular speed. So students, first of all, remember, just recall one thing. What is the difference between the speed and the velocity? So students, remember that the speed is the scalar quantity. Scalar means having magnitude only, and velocity is the vector quantity, means it has magnitude as well as direction. And how we are going to define the speed? Speed means it is the ratio between distance and time, means the rate of change of distance with respect to time, and velocity is displacement over time. Okay, so how we are going to define angular speed? So as we have started in the previous slide, that this is the angle that is 1 radian, and it's a ratio of the length of the arc with the radius of the circle, when this arc length must be equivalent to the radius of the circle. So angular speed is defined as the angle swept out by the radius of the circle per unit time. This angle okay, let me take an highlighter, this angle swept out by the radius of the circle per unit time. So how we are going to write it? Like, look at here, the formula is del theta divided by del t. Yeah, means the angle swept out, the radians or in degrees. Usually it is measured in radians because its unit is radian per second. So angle swept out in radian per unit time is known as the angular speed. And if we add a direction over here, like it is shown in the figure, then it will be known as angular velocity. So the unit of angular speed, or you can say the angular velocity, is radian per second. Okay students, so how we are going to derive the relationship between linear and angular velocity? So students, linear velocity is symbolized as v and the angular velocity is symbolized as omega. So students, you can see from this figure, this figure shows an object traveling at constant speed v in a circle of radius r. Let's say in a time del t, the object moves along an arc of length del s and sweeps out an angle del theta. So from the definition, okay, so from the definition of 1 radian, it is the length of the arc divided by the radius, or if I rewrite this formula, so it will be del theta into r. Okay, so if I divide both sides, dividing both sides by del t, then we can write this equation like del s over del t is equivalent to r del theta over del t. So students, by the definition, for small angles, del s over del theta is the linear speed. It is known as, you can say, the distance over time is known as the linear speed. R will remain same, and del theta over del t is the definition of the angular speed as we have studied in the previous slide. So this is the relationship between v and omega, the linear speed and the angular speed. Okay students, so let's solve a work example based on today's lecture. Okay, so the first heading must be the data. Okay, a rocket makes a turn in a horizontal circle of radius 150 meter. It is traveling at the speed of 240 meter per second. Calculate the angular speed of the aircraft. So the symbol of the angular speed is omega, and we have just started the formula. What is the formula, students? Yes, very good. V equals to r omega, and we have to find omega from here. So omega is equivalent to v over r, and v is given as 240, and when it will be divided by 150, so the answer will be 1.6, and the unit will be radian per second. Okay. Okay, so let us solve one more work example. A car is traveling along a circular path with its linear speed 18 meter per second. Linear speed is symbolized as v, 18 meter per second, and the angular speed is given 0.30 radian per second. What is the radius of curvature of the truck? Okay, so we know that the formula is, what is the formula? The formula is V equals to R omega, and if I need to calculate R, so I will take R on the other side. The formula will become V over omega, and the value of the V is 18 and the value of the omega is 0.30, and when you solve it, so answer will be 60 meters. And that's all for today's lesson. We have covered a significant amount of material, including the definitions of radians, angular speed, angular displacement, or the relationship between the linear and the angular velocity. We have also worked through some example problems to reinforce your understanding. Join me in the next video as we explore centripetal acceleration and centripetal force. Don't forget to like, comment, and hit the notification bell to stay updated on future content. I am grateful for your continued support. Thank you all so much.